Hey guys, we're going to cover lesson 3.4 today, continuing to work with our quadratics. Let me present and we'll get started on this lesson. Okay, so we've talked about solving quadratics by factoring, by completing the square, by square root. Now we're going to look at, and graphing as well. We looked at graphing as well. So we have 4 methods so far. Again, that was graphing, factoring, completing the square, square root, and now the 5th way is the quadratic formula, which again, I know you guys know this from Algebra 1, so some of this will be reviewed, but we're also going to build on what you already know. All right, so it says the solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals negative b plus or minus square root b squared minus 4ac all over 2a. And some of you may have had to sing that to, I think it's like Pop Goes the Weasel. You can like memorize it by singing it to the tune of Pop Goes the Weasel. But in any case, whenever you have a quadratic equation, you can use the quadratic formula to solve. So, we have 5 methods, and I might be asking you to use specific methods at specific times, or there might be a better method, to use in certain situations. But quadratic formula always will work. So if you're having trouble, let's say it's a harder problem to factor, you can always use the quadratic formula. Typically, I try factoring first, and then if factoring doesn't work, I probably just usually jump right into the quadratic formula. Those are the 2 methods that I most often use, but we will be using all 5 in this chapter. Okay, so this is just an example, but we're going to do some examples below. All right, and this is more just, again, stating the quadratic formula. So we're going to be talking about this thing called the discriminant. Okay, the discriminant, if you look at the quadratic formula, it says value of discriminant b squared minus 4ac. So the part of the equation, the part of the formula that's under the radical is our discriminant. We're going to look to see if the stuff under the radical, if it simplifies to a positive number, a negative number, or 0. So if you think about it, if it simplifies to a negative number, what happens when there's a negative under the radical? When it's negative, when it's less than 0, you're going to have imaginary solutions, all right? Which means there are no x-intercepts. The graph is either graphed above the x-axis going up, or maybe it's down here, right? It's an upside down U below the x-axis going down, and it's not going to hit the x-axis. All right, if under the radical is a positive number, all right, so if it's greater than 0, that means there's 2 real solutions, 2 x-intercepts. And then finally, if under the radical it's a 0, that means there's no longer going to be a plus minus. There's only 1 solution, 1 x-intercept, okay? So that's your visual. All right, so it says solve the following quadratic equations using the quadratic formula. All right, so what we're going to do, let me get my pen. So you wanted the steps here. I'm not going to list them because I think you're pretty familiar with them. Let's set it equal to 0 first. That's always the first step. So x squared plus 3x minus 5 equals 0. Then we list our values of a, b, and c off to the side. So a is a 1, b is a 3, c is a negative 5. Then if you don't have it memorized, you might want to say it out loud and write it down every time so that you memorize it. It's negative b plus or minus the square root of b squared minus 4ac, it's a minus 100 times, all over 2a. And from here, it's just plugging in, simplifying, following PEMDAS correctly, and getting your answer. So I'm going to have x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 all over 2 times 1. So cleaning that up. So under the square root, I'm going to square. I'm going to do all my multiplication. So I have negative 3 plus or minus under the square root. 3 squared is a 9. And a negative 4 times a 1 is a negative 4. And negative 4 times a negative 5 is a positive 20. All over, do your multiplication down here, 2. Add under the radical, so negative 3 plus or minus the square root of 29 all over 2. If 29 does not have any perfect square factors, which it does not, you are done. That is your answer. All right. For the next one, again, we're going to start by setting it equal to 0. So I have 25x squared. And I'm going to subtract, I should have done this first, sorry. Subtract the 12x from both sides. Let me erase this, bring it down just a little bit. All right, so I have 25x squared. When you subtract the 12x from both sides, you have negative 20x. I'm also going to add the 4 to both sides. So try and do two things at once. Add the 4 to both sides. So plus 4 equals 0. Now you can identify your A, B, and C values. A is 25, B is negative 20, C is 4. X is equal to negative B, which is negative 20, plus or minus the square root of B squared, that's negative 20 squared, minus 4AC, it's all under the radical, all over 2A. All right, so lots of cleaning up to do. The double negative, right? Negative, negative becomes a positive 20, plus or minus. Negative 20 squared is a positive 400, minus 4 times 25 is a negative 100. Negative 100 times 4 is negative 400. All over 2 times 25 gives you a 50. 400 minus 400 gives you a 0. So you have 20 plus or minus root 0 over 50. Remember we said when there's a 0 under the radical, there's no longer going to be a plus and minus. That's going to disappear, which is why there's only one solution. X is equal to 20 over 50, which is going to simplify, right? They're both divisible by 10, knock off the zeros, 2 over 5. So you have one x-intercept, one solution. Right? And that is 2 over 5. Oh, wrong button. Okay. And this last one, let's subtract 13 from both sides to get started. So I have negative x squared plus 4x minus 13 equals 0. A is equal to negative 1. B is equal to 4. C is equal to negative 13. I have x is equal to negative b plus or minus the square root of b squared minus 4a, I can't even read my own handwriting, c all over 2a. Okay, so cleaning that up, of negative 4 plus or minus the square root of 4 squared is going to give you 16. And then a negative 4 times a negative 1 is a positive 4. A positive 4 times a negative 13 is a negative 52. All over 2 times negative 1 is a negative 2. Do the subtraction under the radical. So negative 4 plus or minus the square root of negative 36 over negative 2. I'm going to bring it up over here. Sorry, I'm working kind of crazy over here. Okay, so the negative 36, that is imaginary, but it is also, oh goodness, it's also a perfect square, right? So, come on, pen, don't go crazy, don't go crazy. Okay, so I have x is equal to negative 4 plus or minus 6i all over negative 2. Okay, 4 and 6 are both divisible by 2. Negative 4 divided by a negative 2 is a positive 2. And then because this is plus minus, a positive 6 divided by a negative 2 is going to be a negative 3. And a negative 6 divided by a negative 2 is going to be a positive 3. So it's still plus or minus 3i. Okay, so again, remember what I said above when we were looking at that chart. If under the radical is a negative, you end up with 2 plus or minus 2 imaginary solutions. It has an I. When it was a 0, like problem 2 was a 0 under the radical, there is one solution. And problem 1, there is a positive number under the radical, and there were 2 real solutions, okay? All right, let's move down to the next set of problems. The next set of problems, just seeing how many I have, okay. So 3 more and then a word problem. The next set of problems ask you to determine the number and type of solutions each quadratic equation has, then find the solutions. So we're going to be using the discriminant here. So the discriminant, remember that's the part that's under the radical, which is b squared minus 4ac. So you have to identify your a, b, and c values like we normally do. A is 1, b is -6, c is 10. So it's -6 squared minus 4 times 1 times 10. So that's 36. And, oh, come on, pen, stop. Okay, so it's 36. And then a -4 times a 1 times a 10 is a -40. So 36 minus 40, you know it's going to be negative, right? It's going to be a -4. So because it's negative, that means that there are 2 imaginary solutions. Now it says to find the solution. Well, here's the cool thing. After you find the discriminant, you're almost kind of done the quadratic formula, right? Because the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Well, we already did this part of it. That's what this work was. That's what this all above here was. So I already know underneath the radical is going to be a -4. So I have x is equal to, and I'm going to plug in the b value now, -6 square root of -4 over 2 times 1. I can clean up the double negatives. So that's 6. Oh, I forgot the plus minus. Sorry, guys. It's plus minus. Plus minus. The square root of -4 is a 2i all over 2. Both 6 and 2 are divisible by 2. So I can simplify that by writing 3 plus or minus 1i, or just I. You don't need the 1 there. Okay, let's try another one. Why is it not deleting? There we go. Okay, so again, list the values of A, B, and C. A is 1, B is -6, C is 9. Discriminant is B squared minus 4AC. So it's going to be -6 squared minus 4 times 1 times 9. So it's going to be a 36 minus 36, which gives you a 0. If under the radical there's a 0, that means that there's one real solution. So again, now we're going to use the quadratic formula, but we're already kind of done. It's -b, which it's, remember this is a -6, -6, plus or minus the square root of the discriminant, b squared minus 4ac, so we know that that's a 0, all over 2 times a, so 2 times 1, okay? All right, so I have a -6 is a +6, plus or minus 0 disappears, that's no longer there, so it's just +6 over 2, and +6 divided by 2 is a +3. So this parabola has one x-intercept, one root, and it is a +3. It crosses the x-axis just at 3, touches the x-axis at 3, okay? And the last one of this type. So again, I'm going to list my values of A, B, and C. I have 1, -6, and +8. So B squared minus 4AC. I'm going to have -6 squared minus 4 times 1 times 8. So it's going to be a +36 minus a +32, which is going to give you a +4. Because under the radical would be a positive number, positive, that means there's 2 real solutions. Okay, So to find those solutions, use the quadratic formula, negative b, which is -6, plus or minus the discriminant, square root of the discriminant, all over 2 times a. Okay, so clean it up. You have a +6 plus or minus 2 over 2. Remember, 2 real solutions. You have 6 plus 2. 6 plus 2 is 8. And then 8 divided by 2 is 4. And then you have 6 minus 2. 6 minus 2 is 4. And 4 divided by 2 is 2. So you have 2 answers here. You have x is equal to 4 and x is equal to 2. Those would be your 2 x-intercepts, your 2 roots, your 2 solutions. All right. And the last problem for today. Okay, this one says a baseball player hits a foul ball straight up in the air from a height of 4 feet off the ground with an initial velocity of 85 feet per second. Then it says write a quadratic function that represents the height h of the ball t seconds after it hits the bat. Okay, so first off, I would give you this function. Forgot to get my pen. For this problem, I would provide for you the following. H is equal to -16t squared plus v sub 0 times t plus h sub 0. And v sub 0 stands for the initial velocity. And h sub 0 stands for initial height. So that information would be provided if I give you a question like this. So to write the quadratic function, you're just going to plug in the initial velocity and the initial height that are given in the word problem. So it would be h is equal to -16t squared plus, they said the initial velocity is 85 feet per second, so 85 times t, plus the initial height was given as 4 feet. Okay, so that would be part A. And then it says, when is the ball 110 feet off the ground? Explain your reasoning. Well, where would the 110 go? Would it go in for time or would it go in for height? It would go in for height. So you'd plug in 110 equals -16t squared plus 85t plus 4. Now, these are some big numbers. If I was asking you to solve this, which you are asked to solve it, you would not want to solve using factoring. You'd want to use the quadratic formula. So you need to set it equal to 0 to start. You have 0 equals -16t squared plus 85t minus 106. And then you would do the quadratic formula from there. Okay, I'm going to give you the answers, but I want you to take a minute, pause this, take a minute and work through this equation. A is -16, B is 85, C is -106, and plug into the quadratic formula and make sure you're able to get T is equal to 2 and T is equal to 3.3125. Okay, so the ball is 110 feet off the ground at 2 times, because think about it, the ball gets hit up in the air and then comes back down. So if we were to graph this using the graphing calculator, we would see that like maybe right here, it's 110 feet, and then over here, it's 110 feet again. So it took 2 seconds to get to this spot, and then 3.3125 seconds to get to that spot. Okay, that's just a very rough sketch of the situation. Now, the last part says the catcher catches the ball 6 feet from the ground. How long is the ball in the air? All right, so what changes? What changes? What do we have to do? All right, we want to know if the ball's height is 0, so I'm going to plug in 0 for the h. What is the time? But our function changes. It's no longer an initial height of 4, it's an initial height of 6, okay, because it says the catcher catches the ball 6 feet from the ground. So it's 0 equals -16t squared plus 85t plus 6. So you'd want to solve that equation, and same thing, you're going to use the quadratic formula. I'm going to let you do that on your own, and you're going to see what the values are for t. You should get t is approximately negative 0.06967, and t is approximately 5.34. We're going to ignore the negative solution because time can't be negative. So that means that it took about 5.4, if you round to nearest tenth, 5.4 seconds. Okay. All right, guys. So that is it for this lesson. Just get back to you so I can say goodbye. That is it for this lesson. So I'll see you back here for the next one. Bye.